Hi, sixth graders. We are still on Unit 3A. Our title of our lesson is Least Common Multiple. Make sure you have that at the top of your page so you know what your notes are on. Okay, least common multiple. You find it in a similar way. The methods are similar to greatest common factor, but obviously a little bit different. So least common multiple is two or more numbers being the least of their common multiples excluding 0. And reminder that a multiple is the product of a number and any whole number. Remember, if we have 5, our multiples would be 5, 10, 15, 20, and so forth. So if we want to find the least common multiple of 6 and 10, so basically, in 6 and 10, there's multiples. If I were to list out all the multiples of 6 and all the multiples of 10, we will get some of the same numbers. They have same multiples, which is common multiples. We want to find the lowest one. So method 1, so I would write find the least common multiple of 6 and 10. Method 1, I have 6. So I'm going to start listing out some of the multiples. So 6, 12, 18, 24, 30, 36, and I'm going to stop there for now. Then I'm going to do 10, and I'm going to do 10, 20, 30, and as I get to 30, I can see that 6 also has a multiple of 30. So I can stop there because even if there's another one that is in common, 30 is going to be the least common multiple. So the least common multiple is 30 of 6 and 10. Okay, we can also use prime factorization. So 6 and 10. So I can factor this out to 2 and 3. Circle my prime numbers. Factor this out to 2 and 5. Circle my prime numbers. Again, because 2 times 3 is 6. 2 times 5 is 10. So I'm going to list them out now. 2 times 3 and 2 times 5. So the way we find the least common multiple this time is we take one of every single prime number that is represented between the two numbers that we're using to find the LCM. So there's 2 2's, but because they're both the same power, they're basically like 2 to the power of 1, I'm just going to take 1. So my 2's are represented. I'm going to pull out a 2. There's a 3, and there's a 5. So I'm using every number, and if there's multiple of numbers, I would take the one with the highest exponent. So then 2 times 3 is 6, times 5 is 30. Same thing, obviously, because we're doing 6 and 10. And then last method is the cake method, which we talked about in the greatest common factor video. And you start and you do it the same way, basically, to find the greatest common factor. So remember, we have 6 and 10. And then we find, or we think of a number that both 6 and 10 can be divided by, which I know they can both be divided by 2. So I pull my 2 out there. Then I divide, so 6 divided by 2 is 3. 10 divided by 2 is 5. There's not a number that 3 and 5 can both be divided by. So my least common multiple is going to be this whole thing, which kind of looks like an L. So 2 times 3 times 5. 2 times 3 is 6 times 5, and we get 30. Remember that these numbers on the side, and this one is only one number, but the ones just on the side is the GCF, and that tells us that the GCF is 2. So the greatest common factor of 6 and 10 is 2, and the least common multiple is 30. Factors are going to be the same or less, and the multiples are going to either be the same or more. All right, so we have 45 and 75, and we're going to find the least common multiple using our different methods. So the first method that we're going to do is listing out our multiples. Sometimes listing out the multiples is the best method to do, and sometimes you sit there for a really long time and going really, really far out. So that's why it's important to know both methods, because if I start with high numbers, I might have a really, really, really long list of numbers, and when it gets higher, then sometimes we make a calculation error. So let's start though. 45, 90, 135, 180, 225, 270, 315. I'm going to stop there for now and just start doing my 75 and see if I run into it. So 75, 150, 225, 300, but I can see that I do have a common multiple, which is 225. So listing out the multiples, it did end up working. Tells me that the least common multiple is 225. If I'm going to use prime factorization, so 45 and 75, so 5 and 9, 5 is prime, and then 3 and 3. So we have 3 times 3 times 5. This time I am going to use my exponents. I'm going to rewrite it. 3 squared times 5. And then I have 75, which is 5 and 15. And then 3 and 5. So then this way I'm going to write it as 3 times 5 squared. So this is where it gets a little bit confusing. So I have 3 squared times 5 and 3 times 5 squared. I know that it's going to include a 3, and I know it's going to include a 5. It's just how many of each. So since they both have a 3, I'm going to take the 3 squared because my exponent is higher. And then that gets rid of this 3. The 3 squared is representing the 3's that I'm pulling out. Just like the 5 squared is going to represent the 5's being pulled out because that has a higher exponent. So then my LCM is going to be 3 squared times 5 squared, which is 9, times 25, which equals 225 as well. Okay, I would like you to try to do these 3 and then come back and check your work. So for 3 and 12, I'm going to just list out my multiples. So 3, 6, 9, 12. As I'm listing them out, if I come across my other number that I'm trying to find a least common multiple of, then I know my least common multiple is just going to be 12. Because the multiple can be between 2 or 3 numbers. It can be the same as or greater. For 10 and 12, I'm going to use we'll use the prime factorization method. So 2 and 5, and then 2 and 6, and 2 and 3. So let's list this out. We have 2 times 5, and then 2 squared times 3 times 5. So there's a 2, there's 2's, there's 3's, and there's a 5. There's 2's in each one. I'm going to take the one with the highest exponent. So 2 squared. Then I like to just cross it off so I know I've already pulled it out. There's only one 3, so I need to use that. And then they each have a 5, but they're both just 5 to the single power. So we have 2 squared times 3 times 5. 2 squared is 4 times 3 is 12 times 5 is 60. And then I always ask myself when I get my answer, is 60 a multiple of 10 and 12? Yes, because I know that 10 times 6 is 60, and I know that 12 times 5 is 60. So that one would work. And then 25 and 30, we'll use our third method. So 25, 30. I know they can both be divided by 5. So 25 divided by 5 is 5. 30 divided by 5 is 6. Oops. 6. Nothing else can be divided by. So I know that my answer is 5 times 5 times 6. 25 times 6 is going to be 100. Is that correct? Yeah. 25 times 6. So 12, 15 is 150, which makes sense because I know 25 times 6, which I just did, obviously, is 150, and then 30 times, what would it be? 30 times 5 is also 150. The 6 is throwing me off there. All right. Lucy needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12. Napkins come in packages of 16, and cups come in packages of 8. What is the least number of packages she will have to buy if she wants to have the same number of plates, napkins, and cups? So that's basically saying, what is the least common multiple of 12, 16, and 8? So 12, 16, and 8. So 12, 24, 36, 48, 60, 72, 84, 96, 108. 16 is going to be 16. Whoops. 32, 48, 64, 80, 96. I can see that 12 has a 96. 16 also has a 96. The other thing is 16 is a multiple of 8, which means all of the multiples of 16 are also going to be multiples of 8. Because if we start 8, 16, 24, 32, 40, 48. There's just that, there's 8 and then there's 16, the 32, the 48 match up. So they're all going to match up. So if 96 is a multiple of 16, it also means it's a multiple of 8. So 96 of each is what she needs to get. So she'll have 96 plates, napkins, and cups of each. So then it asks, what is the least number of packages? So if she needs to buy 96 plates, we would do 96 divided by 12. We can also see right here that one package is 12, 2 will have 24, 3, 4, 5, 6, 7, 8. So either way, you could have just counted out your multiples or did your division. And then napkins come in packages of 16. So one package, 2, 3, 4, 5, 6. So 6 napkins. And then 8 is, so that means we would need double the amount of cups. So then it would be 12 cups packages. So not only did we find the least common multiple, but then we needed to use that to figure out how many packages we needed of each. Make sure your notes are in your backpack as well as maybe you need to get more pencils. If you need pencils or other supplies, this is a good reminder to see what you need, paper, other things. Get it all in your backpack so that you have it for school tomorrow. Have a wonderful night.